Hello. So I am going to run through 9.2. We are dealing with general angle measurements and radian measures. So this piggybacks a little bit off of 9.1. You'll see some familiar things going on, but this is really moving towards angle measurements. So we saw in 9.1 that an angle or a triangle had a total measurement of 180 degrees. Today we're going to work a little more with a circle has a total angle measurement of 360 degrees. So we're going to start with just some general knowledge and notes. So a lot of what we're going to work with today is going to be off of a coordinate plane. So as much as we're going to look at angles, that is sort of our our backbone of where we're going to put all of our work today. So if we have an angle at the starting position, the normal starting position starts at the 0. Your first ray is going to be your initial. So it's basically saying your starting point. And then wherever your angle ends up is your terminal. And you'll see this word come back into play later. So your initial angle is sort of always going to be at 0. And then wherever your angle ends up is going to be your terminal side. And I do have all of these notes on Google Classroom if you want to kind of look at them a little bit differently. So if you're measuring a positive angle, you're going to go counterclockwise. Meaning if I'm saying that this is 120 degrees, it's positive, which makes sense. You're going to go counterclockwise. Opens up, counterclockwise. If you're trying to figure out a negative angle, you're going to go clockwise. So it's just the opposite. So you'd start at your initial and you're going to go down. Clockwise would indicate that it is a negative angle. So we're going to start by drawing some angles. So example 1, draw an angle. Sorry, I cannot talk and write at the same time. So first one we're going to do is 240 degrees. So like I said, you're always going to do, that's your base, your coordinate plane. And what I think is important with this is to write out your angle measurements. It keeps you kind of on the right path. So this is your starting point. So this is 0 degrees. Then you go up 90 every time. This is a right angle, so therefore this is 90 degrees. So if each quadrant is 90 degrees, that makes this one 180 degrees. That makes this one down here 180 plus 90, 270, and then we're back. A full circle, a full revolution would be 360 degrees. So it says 0 and 360. You start at 0, but when you go all the way around, you've now had 360 degrees. That's why I'm putting both numbers there. All right, so let's start. Our ray is going to be at 0. That's our initial. And we're basically going to say, okay, how many times do we need to go sort of around to get to 240? Well, that's 90 degrees. That's 180 degrees. So we basically, to get to 240, need to be somewhere in between 180 and 270. So we're going to be about halfway through. Because 180 plus 60 is 240, and then plus 30 is 270. So it's a little bit more than halfway is your 240 degrees. Simple as that. So let's look at one that's a little bit bigger than 360. So 500 degrees. Again, start out with your coordinate plane. 0, 90, 180, 270, 360. So in this case, I'm going to write more than 360 because we have an angle bigger than 360. So whenever you have something more than 360, you just keep adding 90 to it every time you go to a different quadrant. So 360 plus 90 is 450. 450 plus 90 is 540. There you go. Don't need anything else other than that. So here, you're going to start at your starting spot. And you're going to say, okay, I need to go around at least once because I know that that's 360. I need to go to 450. And then again, just like this one, I need to sort of be halfway through. 50 this way, 40 this way. So I'm going to get a little more than halfway. And that is 500. So you do need these revolutions to be shown because this also could sort of look like 120. So you do need this little indication showing that you've gone past 360 and then some. All right, the last one we're going to do is going to be a negative angle. So we have negative 50 degrees. So this one's going to be set up a little bit different. I don't want to write 0, 90, 180, 270, 360 because none of those apply. I will write 0 because that's always sort of my starting spot. But remember, we said negative angles go clockwise. So now instead of going 0, 90, we're going to go 0, negative 90 down here. Then negative 180. Then negative 270. And this would be negative 360. So we're going to start at 0. And now we're going to say, okay, we need to go to angle 50. We don't want to go past 90. We're middle is 45, so we're going to go a little bit past that. Negative 50 degrees. Short and sweet. Just a little dip. But again, going this way and making the revolutions this way shows us that it is a negative angle. All right, so I talked about this having to show the revolutions because otherwise it might look like 120. That is called a coterminal angle. You'll see this word a lot. So a coterminal angle is basically two angles that share the same terminal side. We'll say 2 or more. Remember, our terminal side is sort of the side that stops the angle. That's our initial. Our terminal is where it ends. So 2 more angles that share the same terminal side. So like I said, 500 also could be 120. Or sorry, 140. Because this goes around 360 and then stops. 140 would just be shoop, looking like that. So that's sort of our first example, 500 and 140. Okay, so you find this, obviously you're not going to like draw this every single time you go through. You find by adding or subtracting multiples of 360. So multiples of 360 would be 360, 720, 1080, 1440, and that's probably about all that you need. So let's go through some examples to kind of show you what I mean by that. So we're going to find one negative and one positive coterminal angle. Coterminal. Told you can't talk and write at the same time. So the first one we're going to look at is negative 45 degrees. So we're saying, okay, if that, sort of like that, what is one negative angle to that and what's one positive? So you literally take negative 45 and you add 360 to it and you subtract 360 from it, both ways. So negative 45 plus 360 is going to be positive 315, so one positive angle. and negative 45 minus 360 is negative 405. So those are both a positive and a negative angle that are coterminal. They would look like they are in the same spot on a graph. Let's try a bigger one. So 395. So you take 395 plus 360, 395 minus 360. So this is going to be a big angle. 395 plus 360 is 755. 395 minus 360 is 35 degrees. And you might say, that's not a positive and a negative, that's a positive and a positive, and you would be right. So then you sort of have to go towards one other type. So let's do 395 minus 720, and we get negative 325. There's my positive and my negative. So if it's above 360, that's when you'll have to start using these bigger angles as you go. All right, so that deals with general angle measurements, that deals with coterminal angles, but the second part of this lesson is radian measures. So let's talk about them. So radians are a different way of talking about angles in a circle other than using degrees. Now, for the notes, I wrote out sort of a longer definition on the paper notes that I threw out on Google Classroom. I'm not going to write all of that because you know how well I talk and write at the same time. So I'm going to talk you through it. So your radian measures, I'm going to draw us a coordinate. Like I said, very similar to degrees. They kind of go hand in hand. You're basically saying that if this was your angle, your radian measure is sort of called your arc. So it says angles can be measured in radians. To define a radian, consider a circle with a radius r centered at the origin shown right here. 1 radian is the measure of an angle in standard position whose terminal sides intercept the arc of length r. So it's saying the terminal side intersects this to sort of get your radian. So the unit circle is a circle with a radius of 1. So your unit circle is sort of like your basic standard circle. We're going to deal with the unit circle later in 9.3, but it's sort of like your base to everything. You're going to get a chart that everything goes with the radius of 1. And then obviously there's times where it gets bigger than that and things like that. But this is sort of your basic standard version. Okay, so I will write one note. Because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. So remember, 2 pi r is your circumference of a circle. All right, so we're going to run through basically swapping back and forth between radian and degrees. So to find radian. So to find radians means you don't have them. And this is when you're given a degree. So to find radians, you take pi over 180 and you multiply it by your given degree. You almost do the exact opposite to find degrees. So if you're looking to find degrees, you're going to take the reciprocal of it, 180 over pi times radian. When you're looking for radians, you're always going to have pi in the answer. Radians always have pi in answer. Degrees obviously don't. Degrees would be 45 degrees, 180 degrees, 70 degrees, 36 degrees. So degrees, just you should end up with a regular total normal number. Radians, you're going to have pi in the answer. So let's see what I'm talking about. So we're going to convert 125, degrees to radians. So I look up top and I say, which one do I want to use? If I have degrees and I need radians, I'm going to go with the first one. So I'll take pi over 180 times my given degrees. And I do not want to shove this whole thing into a calculator, because remember, I want to have pi in my answer. If you put this in a calculator, that's going to turn into a decimal. So you just multiply it straight across. 125 pi equals 180. And I know and you know that that definitely can be reduced. It winds up being reduced if you divide by 5 to 25 pi over 36. What a beautiful answer. So then, example 2, you guessed, we're probably going to be finding degrees. So convert negative pi over 12 into degrees. So again, pi over 12 means that's a radian answer because it has pi in the answer. Into degrees, well, we want to find degrees, so now we flip it. We're going to take 180 over pi times negative pi over 12. You will notice that every single time you do this, these pi's are going to be on opposite sides, so you can cross them out. Don't forget about this negative though. So this turns into negative 180 over 12, which reduces nicely to negative 15 degrees. So remember, degrees turns out to be a whole number. Radians should have pi in the answer. And a lot of the times will be a fraction, but doesn't need to be a fraction. So on your assignment for tonight is to do numbers 1 through 11 on practice A. Keep in mind, there's a lot of answers that look like this. You do have to change them into degrees first and then find your coterminal angles and or graph them. So you're going to be using this right off the bat when you start with numbers, I think 3. All right, good luck.